Okay, now that we know how to complete the square, and we're pretty good at it, I want to complete the square in general without numbers, or with all numbers, any number you can put in there. So instead of having something like 3x squared plus 5x minus 8 equals 0, and we'd move over the 8, and we'd factor out the 3, and we'd do all those steps, I don't want to have any digits. I don't want to have the 3, the 5, or the 8. I want to do it in general so that anything could be the 3. So I'm going to let 3 be the variable A. And anything could be the 5. So I'm going to call that one, whatever that is I'm going to call it B. And the negative 8, whatever that is, I'm going to call it C. So this equation really looks like AX squared plus BX plus C equals 0. And now I'm going to complete the square. Okay. So watch what happens here. I'm going to move the C to the other side. Okay, that gives us AX squared plus BX equals negative C. This first, whatever's on the X, like the 3, can't be on there, so we have to divide it out. So I'll go ahead and divide it out. AX squared divided by an A just leaves an X squared. Now, B divided by A. Well, that's just B divided by A. We're going to leave that space. So that just divided out, factored out the A. The next thing we do is cut this in half. So I have to cut this number in half right there. Well, the way you cut a fraction in half is you double the bottom. So that will be B over 2A. And then we square that into the whole. So I'm just completing the square, only I'm doing it with variables instead of numbers. Well, B squared is B squared, and 2A becomes 4, because 2 squared is 4A squared. So I added B squared over 4A squared on this side. So I have to add B squared over 4A squared on this side. But we haven't multiplied it times A yet, so it was really this whole thing times A. Now, if you'll notice, one of those A's can cancel out one of those A's, and it was really just B squared over 4A. Okay, the reason we write down this in-between step is because that's the factor, so let's keep going. I have this A on the outside, and then this factors to X plus this number all squared, so it'll be X plus B over 2A all squared. And then it equals this stuff over here. So it equals, I'm going to turn it around. I'm going to put the positive piece first. So it equals B squared over 4A minus C. Now, it would actually be nice if this could multiply together. And so if I just got a common denominator, that would be C over 1. So if I multiplied by 4A over 4A, I would have that. So now I could call this A times X plus B over 2A all squared. And now the 4A is the common denominator. So I can just put all this stuff on the top. B squared minus 4AC. Okay, so I'm going to divide off this A, or multiply off this A. So I'm going to multiply by 1 over A, so it cancels out on this side. If I multiply this whole side by 1 over A, I'm going to multiply this side by 1 over A. Now I have X plus B over 2A all squared. And that puts an extra A on the bottom, so I've got B squared minus 4AC 4AA, so over 4A squared. Okay, I'm trying to find the answers to X, so I'm just going to solve this for X now. So like one of the previous videos, we solved this by square rooting both sides. I'm going to square root both sides. That square and that square cancel out, and we have X plus B over 2A. Over here, square rooting in something gives us the positive and the negative answer of it, but now look at the bottom. The square root of 4 is 2, and the square root of A squared is A. So the bottom actually comes out of there as a 2A, but the top does not. So we'll just leave that as B squared minus 4AC. And I'm gonna pick this piece up and put it to the other side, so it will become negative. So I end up with x equals, so this b over 2a, I'll put that first, so it becomes negative b over 2a. And there's a plus and a minus, the square root of b squared minus 4ac, all divided by 2a. Now take a look at these two things. They have a common denominator, so we could just write it all over 2a. So I could put everything over 2a, and then on the top it could be negative b plus and minus the square root of b squared minus 4ac. Okay, that's the quadratic formula. That's this. Have it written down in your notes somewhere if you don't have it memorized. Okay, so the quadratic formula is x equals negative b over 2a, or negative b plus or minus b squared minus 4ac, all divided by 2a. I'll just put the 2a once. That's the quadratic formula. Now, what that does is, see, what we did to get that was to complete the square. This is a shortcut for completing the square. We can find the zeros. This finds zeros in a really quick way. It finds zeros where we can now maybe use our calculator or do it without having to complete the square and take all those steps. It's just a formula. The B and the A and the C and that A, they're all numbers that we just plug in. Now look how it was started. It started like this, in order. X squared, x, no x's, and it's equal to 0. So if we want to use it, we have to organize our starting parabola, our starting quadratic like that. It has to go in order of powers going down. Squared, first power, no power. So down here, I need to take this 11a and move it over there and put it in order. That'll do two things. It'll make this side 0, and then I'll put this stuff in order. So I'm going to start out, this as really it's 5a squared. The 11 when it comes over is plus 11a. The minus 16 is still there, and now it's equal to 0. Okay, that number, now I should have made that an x. That number is the a number, this number is the b number, and that number is the c value. So all we have to do is go plug it in this order with those values. So x is negative b. So the 11 right there is b, so I need the opposite of that. So it's going to be negative 11. Plus or minus, now remember there are always two zeros. There's one to the right and one to the left. This is where they're going to come from. Plus or minus the square root of, okay, now I need b squared. I need the 11 squared. Well, that's 121. Then there's a minus from the problem right there, so minus, and then the number 4 times the number 4ac, so times the number a times the number c, which is negative 16. And then it's all divided by 2 times the a number, which is 5. So it's all divided by 10. Okay, so we've got to get this. So here's it's a minus, and then this will all be negative. So it's going to be 121 plus all of that. So when I use my machine, I'm going to go 4 times 5 times 16. So 20 times 16. 4 times 5 is 20. Is... what the heck? Okay, 320. So this is negative 11 plus or minus the square root of 121 minus 320. So I'm going to add 121 to that. So it's 441. All divided by 10. Okay, those are the values for x. Now, let's see. I think 441 has a square root. Is that a perfect square? Yes, it's 21. So this number right there is really 21. So we have x equals negative 11 plus or minus 21 all over 10. Okay, that's two answers. That's negative 11 plus 21. So negative 11 plus 21 is 10 over 10. So one of the answers is 1. And then I'll use the minus. Negative 11 minus 21, that's negative 32 over 10, or negative 3.2. Okay, so those are the zeros. 1 and x at negative 3, so 1, 2, 3.2, right about there. Okay, as before, we need the zeros, the vertex, and the two dots next to the vertex. Okay, so there's the zeros. I'll just call Z right here. The zeros are at 1, 0 and negative 3.2, 0. Now I need the vertex. Okay, I'm gonna complete the square and show another trick for the vertex. So turn your page over. If we had ax squared plus bx plus c, and we wanted to graph it. Okay, so far doing the vertex, we had to complete the square all the time. Well, we could maybe just complete the square by formula and see if we can't come up with a formula for the vertex. So let's see if we can't do that. When it was equal to y, completing the square was basically the same thing. I'll move the c over there. So we have ax squared plus bx equals y minus c. I still have to divide out the a, so I'll do that. This whole term divided by a leaves x squared. B divided by a leaves b over a. I have to cut that in half, so that's b over 2a. And I square that in, so that will be b squared over 4a squared, because we're squaring the bottom. Okay, so here on this side I got to add it over there too. So here I have a b squared over 4a squared times a. So one more time, that a will cancel out one of those a's. So really I added b squared over 4a. So if I added b squared over 4a there, I'll add b squared over 4a here. See what I did? I had to take this b squared over 4a squared and multiply it by another a, so those a's canceled out. That's where that came from. Okay, so factoring, I've got an a and then an x plus b over 2a all squared. And over here, I've got a y minus c plus b squared over 4a. Now, just because I have a feeling it will make it easier, I'm going to write this in the other order. How about y plus b squared over 4a minus c? I haven't really done anything, I just switched those around. Okay, I'm going to multiply both sides by 1 over a just to get that to cancel out. So I'm going to multiply this side also by 1 over a. Okay, that's legal as long as you do it to both sides. So we have x plus b over 2a all squared equals 1 over a, and then this stuff, y plus b squared over 4a minus c. Okay, this is that transformational form that we did at the very beginning. Here's the vertex. The vertex is what makes this piece 0. Well, negative b over 2a makes that piece 0. And it's what makes this piece 0. Okay, so I need this piece to be 0. So I'm gonna do a little thought bubble over here. I need something plus b squared over 4a minus c I need all of that to add up to 0. Well, the y then would need to be a negative b squared over 4a plus c. If I substituted that in for the y, see, just like right here, we're substituting in negative b over 2a in for the x, and that makes it add up to 0. Well, if I substitute in a negative b squared over 4a and plus a c, now all that adds up to 0. So the 0 for this is a positive c, and then a minus b squared over 4a. There's the vertex. And look what the inverse number is there. Here's the slope, the multiplier. The y's are going to get multiplied by a. That's really what I was looking for right there. The y's are going to get multiplied by a. Whatever the a number is, that's referring to it all the way back up here. That leading number, whatever that is the y multiplier. And then the vertex, this is easy to remember. Negative b over 2a. You could remember this piece also. So you could put this down in your notes and get the vertex by formula. And then the y multiplier is always the a number. Okay, so let's see if we can't use that to our advantage. I need the vertex. Okay, the vertex is negative b, so that's the negative 11, over 2 times a, so 2 times 5 is 10. So the vertex is at the x part is at negative 11 tenths. The y part, now there's 2 ways you could do this. If we know what x is, you could just stick it in and solve it for y. I could think of this as, if I stick this, let's see. If I plug negative 11 tenths in for the x, it will tell me what the y was. So I can do it 2 ways. I can remember my formula. The formula is the c number minus b squared over 4a. So that would be the c number, negative 16. So it was c minus b squared over 4a, so minus 11 squared over 4 times a, so that would be 20. Okay, whatever that is. So I've got negative 16 minus 121 over 20. So it's negative 441/20. Now, I actually think that's a little bit hard to remember. This is kind of a hard little formula to remember. Negative b over 2a is easy to remember. It's basically the first part of the quadratic formula, negative b over 2a. That's what the x is. If you throw all this out, negative b over 2a is the x part of the vertex. Well, I don't remember the y formula, because if you figure out the x, so I remember the x, if you plug it back in there, it'll tell you the y. So if on the calculator I do 5 times, and then I'm going to plug in the negative 11 tenths squared, and then it's plus 11 times that, so plus 11 times negative 11 tenths, and then it's minus 16. See how it's the same answer, negative 441 over 20. So typically, I remember negative b over 2a and then stick that in the formula, or in the original, to see what the y is. Okay, so the vertex, I would like this as a decimal, so that's negative 1 1/10, so negative 1.1. And 441 divided by 20 is 2205. Okay, so there's the vertex. Negative 1.1, negative 22.05. Okay, so negative 1.1, so it's way down here someplace. So we need both zeros, the vertex, and 1 unit to the left and 1 unit to the right of that vertex. Okay, so the next points. So point number 1. I'm going to go 1 unit to the left. So if I have negative 1.1 and I go 1 more unit in the negative direction, it'll be negative 2.1. Okay, that's what the next point is, what this is. What the whole point of this one is. The a is the y value is always, it's always multiplied by the a. So when I go left 1, it's going to go up 5. So negative 2205 plus 5 is negative 1705. And then the other point, if I take this negative 1.1 and go to the right, that'll be at negative 0.1 and then negative 17.05. Okay, so this has to be on the page. That has to be part of the answer, and then plus the sketch. So we have 5 points. I want to see the zeros, the vertex, the point, and the point. Okay, let's try that all again. Okay, so here we go. If I take all these things and put them both over there, the problem is really negative 11b squared minus 11b minus 11 equals 0. Okay, so I took the 11b, put it over here, and the 11 put it over here. Okay, the zeros. The quadratic formula is negative b, so negative 11 will be positive 11, plus or minus the square root of b squared, so negative 11 times negative 11 is positive 121, minus 4 times the a number, which is negative 11, times the c number, which is negative 11, all divided by 2 times the a number. Okay, I'm gonna do it so that it crashes first. I'm gonna type it in exactly how that is. 121 minus 4 times negative 11 times negative 11. Okay, negative 363. So we have 11 plus or minus the square root of negative 363, all divided by negative 22. Now does 360, if I try to square root negative 363, calculator has a problem with that. This kind of calculator does. It's because it's imaginary. I got to pull that I out of that negative out of there. So now this time I'm just going to see if 363 does 363 have a square root? Okay, it's 11 square roots of 3. So we have 11 plus or minus the imaginary. I'll take the negative out of that square root. 11 square roots of 3, all divided by negative 22. Okay, those are the zeros. Now, I want to be able to plot those. So those are what the x's are. So I do want to get the decimals for those. So I need 11 plus that. Okay, so 11 square roots of 3 is really the number 19, let's call it 19.1. So I have 11 plus 19. Okay, I don't need to know that. It's imaginary. I was thinking, okay, where am I going to put that? The x means it doesn't cross the x values. So I'm going to go ahead and answer those as the 0. So I'll call this 0. It's 11 plus and minus imaginary 11 square roots of 3 over negative 22. So it really means there are no zeros. The zeros are imaginary. Okay, the next thing I want to do is get the vertex. Okay, the vertex is negative b. Okay, so it's going to be negative 11 over 2a. So 2 times negative 11 will be negative 22. So the vertex is at negative 1/2. Now, if I stick negative 1/2 in the first spot and the second spot, it'll tell me what the y part of that is. So on my calculator, I'm just going to have it do that. So negative 11 times negative 1/2 squared minus 11 times negative 1/2 minus 11. So I just plugged it into the original equation. It's 33/4 negative. So there's the vertex. I would like that as a decimal just so I can know where to plot it. So the vertex is at negative 1/2, negative 8.25. So negative 1/2 down 825 is right about there. Okay, this A number is the Y multiplier. That means when I go to the right one, it's going to go down 11. So right one down 11, left one down 11. There's the graph of that thing. So those next 2 points, if I go one more than this, that'll make it positive 0.5, and then it's going to go down 11. So it'll be at negative 19.25. And the other point, go the other way by 1, and it will also be down 19.25. Here's the answer set that I want to see. Those 5 answers. The 2 imaginary zeros, the vertex, and the 2 points, 1 unit to the right and 1 unit to the left of the vertex. Okay, let's try another one. This is really, if I reorganize, I've got 5v squared minus 4v minus 33 equals 0. I just put this 4v over there so it will be negative. The zeros are the quadratic formula. The quadratic formula says negative b, so that will be negative negative 4 plus or minus the square root of b squared. Negative 4 times negative 4 is positive 16. Minus 4 times the a number times the c number, which is negative 33. So now you can already tell this is not going to be imaginary because I'm going to have a negative 4 times a negative 33. It's going to be 16 plus whatever that is. All divided by 2 times a, so 2 times 5, so it's going to be divided by 10. Okay, calculator time. We need 16 minus all of that. So 16 minus 4 times 5 times negative 33. 676. Let me just make sure that the 676 reduces to 26. So this all becomes 4 plus or minus 26 over 10. So that means it's 4 plus 26 over 10. So one of the answers is 3. And it means 4 minus 26. So 4 minus 26 is negative 22 over 10, which is negative 2.2. Okay, so there are zeros. 3, 0, and negative 2.2, 0. So 3, 0 is right there, and negative 2.20 is right there. Vertex. Vertex is negative b over 2a, and then stick that in. So negative, negative 4. So that's 4 over 2 times a, so that's 10. So the vertex is at 0.4. Now I'm just going to go put 0.4 in the equation over here. So it's 5 times 0.4 squared. Minus 4 times 0.4 minus 33. It's negative 169 fifths, negative 33.8. So my vertex is, so here's the vertex in my answer set, 0.4 and then negative 33.8. So over 0.4, way down. Okay, here's the y multiplier. The y's are multiplied by 5 from what they usually do. They usually do over 1, up 1. So my next point, if I go over 1 to 1.4, it should go up 1, but it's really going to go up 1 times 5. So negative 33.8 plus 5 is negative 28.8. That's this point way down here. Over 1, up 5. It's something like that. And then if I go the other direction, 0.4 minus 1 is negative 0.6. That will also be at negative 28.8. Here's the 5 answers. And here's the graph. Okay, and number 7. I'll take these two things and put them to the other side. So I have 5p squared, moving the 2p over makes it minus 2p. Adding 5 over, there was already a 7, so when I add that 5 over there, it makes it plus 12. You know, this time maybe I'll do the vertex first. The vertex is at negative b, so there's the b, so it'll be positive 2 over 2a. So 2 times 5 is 10. So the vertex is 0.2. Sticking in the 0.2. So now I've got 5 times 0.2 squared minus 2 times 0.2 plus 12. 11.8. Okay, so my vertex is 0.2, 11.8. Okay, so 0.2 is barely over, up 11.8 is somewhere right up there. Now, one of the things that I can tell is if I go to the next point, if I go one more over, this is the multiplier, times 5. So it's going to go over 1 up 5. So it's going to be at 16.8. So if I go over 1 up 5, it's like right there. And then if I go the other way, 0.2 minus 1, so negative 0.8 will be up 16.8. Over 1 up 5 is about right there. Here's the graph of that thing. I can tell by the vertex is above the x-axis and then it was pointing up. This is going to have imaginary zeros. It's never going to cross the x-axis. So the zeros here are going to have an I in it. Okay, x equals the the quadratic formula, negative b. So negative 2 is 2, plus or minus b squared. Negative 2 squared is 4, minus 4 times a, which is 5, times c, which is 12. See the imaginary part? 4 minus some big number, that's going to be negative. It's going to be square root of a negative. All divided by 2 times a. Okay, well, let's see what that negative is. This is going to, I can probably do this in my head. 20 times 12, 240. This is 4 minus 240. 4 minus 240 would be negative 236 all over 10. Okay, the square root of 236 is 2 roots of 59. So when I take the imaginary part out, it's 2 plus or minus I. Now, here's how you write that. You put the real number first. So the I will be out, but then I've got a 2 coming out of there. So we usually call that 2I. Square roots of 59, all divided by 10. Now, since we don't actually have to plot those anywhere, we don't need to figure out what those are as a decimal, so we can just call that the zeros. The zeros are 2 plus and minus 2i roots of 59 over 10. Now remember, that's hard to plot anyway because you would go 2 over and up amount and make a ray to it. So the imaginary numbers are in physics. They don't even make sense in this context because when we're crossing just the x-axis, it's doing it imaginarily. Okay, so on the homework, I want to see the graph, and I want to see the vertex, a point to the right, a point to the left, and the zeros for all of them.